and welcome back. I am here today for about an hour, maybe, and then I'm going to be taking off for a couple of days, and won't be back till next week because of Thanksgiving. All right, so I spent about 10 minutes this morning trying to figure out how to get some audio going on in the background, and I still haven't figured that out. I downloaded Loopback, and I tried to set up Pretzel Rocks, and I don't know. I'll figure it out. I should just not do it just before the stream. Okay, so where did we leave off yesterday? We were in the middle of this Drunkard's Walk thing. We gotten it to the point where it could create... Oh, I should change that click sound. There we go. We got to the point where we could create random starting locations for the walk. And then we were about to start this section here, modifying how long it takes for the drunkard to pass out. All right, so let's just make sure. I think we're all clear here. Right? Oh, we're one ahead. Didn't I push this? I guess I did not. There. Okay, there it is. So it's pushed now. Good. So what we're going to start with, let's see. Oh, I want to do that. Just make sure we're clean. And we'll go here. Another parameter to tweak is how long the drunkard stays awake. This can seriously change the character of the resultant map. So, right, drunken lifetime here. All right, let's go ahead and add that. So we have the drunk spawn mode and a drunken lifetime. Okay. And we will tell the random builder to use a shorter lifespan. And that's in mod.rs, right? Drunken lifetime 100. And we'll modify the code to actually use it. Okay. Like that. Drunk life. Instead of 400, we're going to say self settings, drunken lifetime. Simple change and drastically alters the nature of the resulting map. Each digger can only go a quarter of the distance. So they tend to carve out less of the map. That leads to more iterations, and since they start randomly, you see more distinct mapped areas forming and hope they join up. Cargar 1 with 100 lifespan. Okay. Let's do a check. It should all just... Oh, no, we got 2 warnings. Oh, we have 2 warnings because we're probably not using something that we need to be using at some point, right? That's typically what happens. Yeah, we're not using starting point yet. Okay, but I'm sure we're going to add that. Let us do a refresh here and see if we can get a nice drunkard's walk. Nope. Refresh, 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 refresh. We'll keep refreshing until we get... Wow. Random number generator is not being... There we go. About to say it's not being nice. I don't know. It still looks like a big open map with a bunch of little areas on the edges. Oh, because I didn't build it. That's why. Okay. There we go. Okay, now it looks very different, right? That's pretty neat. Yeah. Oh, and then did you see that very last frame? It cleared in all the areas that were unreachable from the starting point. So all the stuff that happened over here, we can no longer get to. because it got erased. Yeah, that closes the map off. Okay. Well, it's definitely different, right? All right, changing the desired fill percentage. Lastly, we'll play with how much the map we want to cover with floors. The lower the number, the more walls you generate and less open area. We'll modify Drunkard settings. To add a floor percent. And desired floor tiles, oops, is going to be self settings floor percent times total tiles as F32 as U size. Oh, okay, that's probably why there was an as U size in here before. We didn't need it, and then now we do need it. Okay. As F32, and we're going to put self settings floor per percent. Okay, 1 second. All right, apologies for the interruption. Let's figure this out. Right, so 4% is 0.4. That's right here. No, it's in the other one, in the other file. Mod.rs. Floor percent 0.4. We should just have those two warnings. Yep. Let's build that. And now we're just going to have a little bit of the map cleared. Right? Once we refresh it enough times. There we go. We know the starting point is going to be okay because our first one is on the starting point. Oh, yeah, I see that? It cleared out a lot. Okay, so that part's working now. And then building some preset constructors. Now that we've got these parameters to play with, let's make a few more constructors to remove the need for a caller in mod.rs to know about the algorithm details. All right, so new is going to do this, and we have open area, open halls, and winding passages. Okay. So we can still create a new with the settings if we want to, but then we also have these preset ones. All right. That seems straightforward. Oops. Oh, I'm still not used to the way NVim does, what's it, drunk, right? Not used to the way NVim does the capital Z, the double capital Z's. Okay. Let us copy this, and we're adding 3 more, right? So new. Well, that wasn't helpful. Maybe I should have done space new. Okay. So we've got, this is going to be open area, and we're not going to pass in settings because we're going to generate our own settings. Drunk spawn mode starting point. Drunk lifetime 400 and floor percent 0.5. All right. Let's copy that one. And this is going to be open halls. So lifetime is 400. Oh, but drunken spawn mode is random. And then last one is winding passages. And this one's 100.4. Okay. And then we can modify our random builder just to select those randomly. Yeah. I tried to be clever. That didn't work. Mod.rs. Okay. So instead of 1 to 5, we're going to change it to 7. And we're going to call open area, new depth, comma. Get rid of all these lines. Add 5 and 6. And this is going to be open halls. And this is going to be winding passages. All right, and that should get rid of the warnings. Oh, I spoke too soon. Oh, we no longer need those. Okay. And then new is never used. Why don't we clean that up? If new is not used, we can make it private for now and have the other functions call it, right? All we need is the Drunkard's walk builder, right? That's all we need. And then in the other one, right, instead of having new as a public, what we'll do is we'll just do that and have this call it Drunkard's walk builder new. We don't have to pass in anything except for the depth and the settings, right? Okay, and then we can eliminate this line here and move that in, right? And then the same thing happens with the open halls. This goes here, this goes in by 3, and we get rid of that guy. And then finally, with winding passages, and this should get rid of that other warning and not have all this code duplication, right? So it's a win-win. Nope, didn't like that. I missed a close like that. Still 3 errors. What's the error here? Unexpected closing delimiter. All right, so I'm still missing something. Oh, this doesn't get one. Duh. This does. I put it in the wrong one. There. Okay, now we got 0, 0. That's good. Okay, so now every time we refresh and it chooses the right one, we'll get a different kind of drunk area. So let's test that out. Oh, there it goes. I was a little too fast on that refresh. So this one looks like a big, maybe that's one's a half one. That one's, I can't tell. Oh, and we got to get rid of this console log here. We don't need that anymore. Oh, and I left one in BSP interior. Okay. There. Okay, that cleans that up. And that's the end of the Drunkard section. Cool. All right, so let's commit this once we format it. Active digger count is not used. Okay. Is there something we... Oh, yeah, we're not using it anymore because we're not console logging it anymore. Okay. There. Jeez. Active digger count. There. Okay. We don't need to report it every time. We don't care about it anymore now that we got it working. If we were doing this right, we'd be writing mod tests, right? Git add source, git commit, finish, up, Drunkard's walk. Code. Sure. All right, so we added drunken lifetime and the 4%. We modified our new to be a private function that these other three constructors call. And then we use those settings there. We remove the extra console log, and we now will create randomly one of those three. Okay. Good. What's next? Next up is scaffolding. A mainstay of dungeon crawl games is the good old-fashioned labyrinth, often featuring a minotaur. Dungeon Crawl Stone Soup has a literal minotaur labyrinth. Tome 4 has the sandworm mazes. One Night has elven hedge maze. These levels can be annoying for the player and should be used sparingly. A lot of players don't really enjoy the tedium of exploring to find an exit. This chapter will show you how to make a labyrinth. If players hate it, we're going to make it anyway. Once again, we'll use the previous chapter as scaffolding instead of random builder uses the new design. Oh, right. So we're just going to copy paste, right? And this is using spawn region. So let's just copy map builders, drunkard walk, to source map builders. And what are we calling it? Maze. Everybody hates a maze. All right. So all of this. Yeah, and again, we're not using specs prelude, so we don't need to worry about that. Random number generator is going to be different. And this we don't need to do because we're pulling it in through the crate here. So I think we're okay with all of that. We can get rid of the drunk spawn mode, drunkard settings. Our map builder changes to be called maze builder. It has a map, starting position, a depth, history, and noise areas. No settings. All right, so drunk, and we'll just call it maze. Right? And then this is going to be simple. There's no settings. Like that. And then these all get deleted. And everything else is the same. Right? Good. And this is the map entry thing that we're going to avoid doing by using the, oh, looks like they don't do it yet. All right, well, we'll see. All right, so our build code changes. The first line's the same. Starting position is the same. What was I saying about it changing? Start index is the same thing. So that's all the same. Map tiles. Oh, this just says while the start index is not a floor, then starting position X minus equals 1. And then we set our start index. So we're going to keep going to the left until we find a starting position. To find an open tile. Okay, so I think we're leaving some code out. Right, and we'll come back to that. The rest is going to be the same. So let's just add this code here. Make that mutable while self map tile start idx is not equal to floor self-starting position x minus equals 1, and then we just grab this again, except we get rid of that, like that. Okay, and then these lines all go away. We don't worry about this part here, right? Digger counts don't matter, and then we have exit tile. All right. We do want to take a snapshot right after, or right before we do that. Oops. There. And then we're going to add our new code somewhere. We're going to add it to random builder. Okay. We need to import it first. Mod maze, use maze builder, and then this becomes maze builder and just new, right? Oh, they didn't add it here. Okay. Oh, okay. I missed this fact. They commented it out here, and they're just going to say build a maze. But that's okay. We can just keep hitting refresh until it works. That's fine. All right, save that one. And now we're going to actually build a maze. So lots of good maze building algorithms out there, all guaranteed to give you a perfectly solvable maze. So then the way he did it in One Night in Dungeon isn't going to work in the type of map we're using. So let's skip forward. Started as C++ code with pointers everywhere and took a bit of time to port. The most basic structure in the algorithm is the cell. And cells are tiles on the map with row, column, walls, and visited. Cell also defines some methods. Okay, so we're going to add a new struct here. I'm just putting it down here at the bottom to keep it all together. I32 walls is an array of 4 bools. A slice, sorry, of 4 bools. And whether or not we visited is a bool. And then we'll implement the cell. Walls gets 4 trues. And visited is false. Okay, so that's that. And now in here, we've got a few functions. Remove walls. And what is this going to do? Self column, next column. Okay, so we're just between 2 cells. We're saying, is there a wall there? Okay. Next row, and I'm going to say if, well, we only do one of them, right? Right? Because if we hit here, if this is true, then none of these will be true. J Dishon, thank you for the follow. So only one of them is going to hit. I think the first term array is correct. Slices one is a reference. Oh, I see what you're saying. Yeah, so if it's ampersand bool, it's considered a reference to a slice, whereas bool is just like this is just an array. Okay. I'll go with that terminology. That sounds reasonable. Self walls left is false. Oops, I forgot to add the constants. These constants just live outside of everything. Right, bottom, and left. 1, 2, and 3. All right, so we have that. Self walls left and next walls right is false. So yeah, it sounds like what we're doing is digging between the first thing that still has a wall between them, right? If x is 1, then the next column must be greater than our column. In other words, the next cell is to the right of our column. So we remove the wall to the right. So it can't be in more than one location. So once we found 1, then we're good. Else if x is -1, self walls right. This is a little tedious to type in, isn't it? Self walls left equals false. You know what we could do? I wonder if we can be a little fancier about this. And do a match. Let lock x. This I'm probably going to break everything if I do this. Lock y equals match xy, right? And then if it's 1 and anything, then we're going to return left and right. If it's -1 and anything, return right and left. And then we'll do the same thing for the y, right? And this will be top and bottom. And anything in -1 is going to be bottom and top, right? And then anything else means we failed. Right? And then all we have to do here is say self walls. Maybe x and y is bad. Mine and yours. Mine is false. Self walls, yours is false. Is that going to break? What am I working on now? Yeah, so what we got through so far, we did, why isn't this thing being good? There we go. It was flickering. So we started this a couple of days ago, this section 3, generating maps. It took a few days to get through the map building test harness and some refactoring code. We did BSP, and I think BSP stands for binary space partition. Yeah, binary space partition. So we did those maps. Oh, I lost my thing here. And we did the interior, we did cellular automata, and we just finished up the Drunkard's walk. And I've got it set up, so all I have to do is hit refresh here. This is the simple map style that we had from the beginning. This is the Drunkard's walk style, where it just randomly carves out sections of the cave using the Drunkard's walk. That's another one. And this one is a BSP map. So it creates all the rooms at once and then it connects them up. And then this is the interior style. I just got lucky there with the RNG. Yeah, so right, the tutorial shows, look how many it's got in here. Like we're doing mazes now and labyrinths, and then diffusion limited, symmetry brushes, Voronoi hive maps, wave function collapse, which sounds like it's going to destroy the universe. So there's a bunch of different things we're going to get through in it. And we don't get to doors until 4.18. All right, so I forget where I was. Oh yeah, so I was just trying to make this a little different-er, right? To make it, we'd pick this. I don't know if this is going to even, it's going to check. I don't know if I've gotten far enough with the other code to... Oh, I didn't say this returns a maze builder. Starting position. And then we have visited here. Help a field with similar name. Oh, I missed. VISITED. There we go. You helped an employee optimize a wave function collapse thing he developed on his own time. I don't even know what a wave function collapse algorithm is, so I'm looking forward to learning about that. And we're still seeing an error here. Oh, it's private. Okay, that's an easy fix. Really? I just made it pub. Oh, I made the wrong thing pub. This should be pub. Okay, so now we're just down to warnings. So this code builds, and I don't know if it works, but we'll find out when we try to run it, and if it fails to connect things up, then we know the first place to look. All right, so that's cell, and now we're going to actually use cell. A cell is part of a grid, so now we're going to create a grid. All right, let's put that down here, if I can get my mouse to behave. Struct grid, and now grid has a lifetime. Where are we going to use that lifetime? Height, cells, backtrace, current, and we get the this is where we're going to use it. So we're grabbing a random number generator. So this time we're passing it through. And that's something that the map code in general needs to have addressed, is passing the random number generator from specs into here. Because right now we have it as a resource in our code, in our ECS, but we're grabbing a new one each time instead of using the one from the seed. So hopefully this is a first step in getting it to be passed around. Right, the tick A is a lifetime param specifier because we need to borrow the random number generator. We have a width and a height defining the size of the maze. Cells are just a vector of the cell type we defined earlier, and backtrace is used by the algorithm for recursively backtracking to ensure that every cell has been processed. It's a vector of cell indices. Current is used by the algorithm to tell which cell we're currently working with, and that's the random numbers generator. All right. So let's start implementing our grid. Whoop. Tick A. Grid. Tick A. I'm putting the RLTK in there because I forgot to import it at the top, and I'm too lazy to go up there now. Let grid width, height, cells gets a new vec, like that. Backtrace, vec new, current 0, and we get the random number generator. Okay. And then we're going to modify it. For row in 0 to height. For column in 0 width. Grid, cells, push, cell. So, okay, so we're generating all the new cells for the grid. And they're all unconnected. And we return the grid that we just made. Okay. So that's our constructor. And now we're going to calculate an index. if rows less than 0 or columns less than 0. Okay, so if, oh, okay, so this is like the map XY kind of thing. And I put new here instead of fn new. Does it have to be public? No. Okay. Calculate index, self row I32, column I32, returns I32, and it's just going to return self height -1, and then that gets -1. Otherwise, we return column plus row times self width. Yep. And then we're going to go get available neighbors. Okay, so it's just putting in the indices for each of the neighbors. And this is using the calculate index we just did. So if it's not -1 and we haven't visited the cell, then we're going to push it. Okay. ABL bores self back usize back new. Okay, and we grab the current row and current column. Right, and then we're going to grab the neighbor indices, which is a 4-way array of I32s. Oops, like this. Self calculate index current row -1 current column, comma. And we just put that 4 times, and this will be +1 without that. This will be +1 here, and this will be -1. Okay. And then we're going to loop over that 4-way neighbor indices iter if star I is not equal to -1, and self sells star I as usize. Visited neighbors push star I as usize. Okay, and then we just return that. So this function provides the available exits from the current cell. It works by obtaining the row and column coordinates and puts it into the calculate index. It finally iterates the array, and if the values are valid, and we haven't been there before, it pushes them into the neighbors list, and it returns the neighbors. All right, so now we have something called find next cell, and then I can see we're almost at generate maze here. Find next cell. It returns an option, usize. Neighbors len is 1, then we return the only one that's there. Otherwise, we roll a die and determine, and just pick one, oops, and pick one at random. Okay. Right, else we're going to pick one at random, otherwise we're going to turn none. And this will just be return some that. Once in a while I'll get lazy and copy and paste it, although I do want to make it look like my code. There we go. Okay, this should give us just warnings, right? Nope. I must have misspelled it. INDICES. Right? Oops. Yeah, okay, so just 16 warnings. And now we're going to generate the maze. Ooh, it's going to look like that. Neat. Okay. I shouldn't have peeked. All right, so we're going to loop. Where do we break? We break over here. Okay. Whenever I see an infinite loop, I look for all the exits from the loop, and I think that's the only one. Self cells, self current, visited. It comes from years and years of doing code reviews. Let next, self find next cell. Match next. Do we need next? Because this is saying some next, because we can just say, yeah, we can just say if let some next. We've done this optimization before with this code. I'm trying to go too fast. Now we have it. So self cells of next dot visited is true. Self backtrace push self current. Okay, so we're working on a backtracing algorithm. That way, once we hit a dead end or reach the end of this section of the maze, we can walk our way back and find the next part to start exploring. So lower part, and then higher part. What do we got? So this and this, this and this. And then what is this going to be? Cell 1. I guess something like this. Cell 2. That looks almost like their comment, right? Lower part, higher part equals self cells split at mut. So this must be a slice function, right? Because cells is a slice, and we're going to split and get a mutable reference to the split. Lower power part. And then cell 2 is the higher part of 0. Okay. Cell 1, remove walls, connecting it to cell 2. Self current is next. Right, else, and this is the none case, if self back trace is empty, there's nothing left to backtrace to. Self current, self back. Oh, if it's not empty, trace. I typed the not and I didn't read it. Backtrace, remove 0. So we're just backing up one position. If there's nothing left to backtrace to, then we break out of the loop. Right? And then self copy to map. Copy to map. We don't have that. Okay. Generator take snapshot. Right. We don't take snapshot anywhere else. So does this do... Okay. We start with loop. It runs forever. We set the value visited to true. So we visited this cell. We add the current cell to the beginning of the backtrace list. That's here. And then we find the next cell and set that to next. Where's that? oh, sorry, if next has a value, then we split the cells into two mutable references. Rust normally doesn't allow this, but we can split our slice to two non-overlapping parts. This is a common use case, and Rust provides a safe function to do exactly that. So that's what the split at mute is. Okay. If next does not have a value, that's this code here, and backtrace is empty, we're done. Finally, we call copy to map, which copies the maze to the map, more on that below, and takes a snapshot. So why does this work? First few iterations will get non-visited neighbors carving a clear path through the maze. Each step along the way we visited is added to the backtrace, right? Effectively a drunken walk through the maze, but ensuring that we cannot return to a cell. When we hit a point we have no neighbors, we're at the end of the maze, and the algorithm will change current to the first entry in our backtrace list and will then randomly walk from there, filling in more cells. If that point can't go anywhere, it works the way up the backtrace list, yep, and repeats for it until every cell has been visited. So here's copy to map. All right, let's do that. And I think that might be all we need to do for this, right? Self and then the map. For I in map tiles iter mute star I equals tile type wall. There's probably a way to do this with like map tiles map or iter map, but I don't know enough Rust to do that, right? X star X equals wall. I don't know. There's probably a way to do that. For cell in self iter self cells iter. So cell column plus 1. Wonder why we're off by 1 here. Row plus 1. Get the XY index of X times 2 and Y times 2. Oh, I see why. Because we're going to shift down 1 to get off this row here, and then we'll multiply everything by 2 because each one of these is really a 2 by 2 section. Okay. Map tiles IDX tile type floor. Cell walls top. So if there's nothing on the top, then map tiles IDX minus map width as use size is tile type floor. Okay, and then we're going to do the same thing with, actually, let me put this on one line because then it'll be easier to copy paste like that. This is right, bottom, and left. And then, oh, this is minus map width. And this is IDX plus 1, right? And this is plus, and this is IDX minus 1. Right? Okay, and that's the for loop. This is where the mismatch between grid cell and our map format is resolved. Each cell in the maze structure can have walls in any of the 4 major directions, but our map doesn't work that way. Walls aren't a part of a tile, they are a tile. So we double the size of the grid, right? So this is like cell 0, 0, cell 0, 1 is here, 2 over, and so on. All right. Now we're only taking one snapshot here. So I'm not sure if we're going to see all this fancy stuff like this. But we can keep hitting reload until it works. We do have 2 errors we need to resolve. I missed a closing brace somewhere. Let's see, that matches that. And that matches that. And that matches the grid there. And this should match the top of this function. Oh. So the error, and I should have just kept reading. The error is here. There we go. That should be self. And then we still have 18 warnings though. What in the world? We're not calling any of these? Oh yeah, we got to modify our... It says speeding it up, but we never call it, right? Unless I missed it way up here. We have to call generate map somewhere along the way. Here's remove unreachable. Huh. Yeah, we're never actually calling the code. Are you using RLTK or are you trying to port the tutorial to bracket on the fly? I'm still using RLTK. It would be nice to modify this to use bracket, but I don't have the brain power to do the tutorial and the port at the same time, unfortunately. So my question is, what's the starting point? I mean, this is generate maze, right? So should we call generate maze from the maze builder? Yeah, there's something missing here. Generate maze. This needs to be called from somewhere. Oh, I see what I did wrong here. This is supposed to be inside the loop, and it's not. Okay, that makes more sense. Now it should do it every time through the loop. Every time we place a new cell, it'll take a snapshot. Okay. But we need to call generate maze. So we have to create a new maze generator. Oh, a new grid. Okay. So we have to add that up here. When we call build, we say let maze, I don't know, equals grid new RNG, or we pass in a mute. Oh, it's already mutable, right? It's already a mutable. Simple grid. Does it take any? Oh, with the height and the random number generator. So the width has to be half and the height has to be half. Let me just see if there's a column missing. Generate maze. No, there's no call to it. All right, so we have to invent this call. And I think it needs to be half, right? So, because we multiply everything by 2, self map width over 2, self map height over 2, right? And then the random number generator. All right. Will this build? Or at least types differ. Oh, I do need to put mutable here. Okay. All right, but we still have 22 warnings. Because we call generate. Oh, we didn't call generate maze. All we did was create the grid. Yeah, and now we have to say maze generate maze. And what are the arguments to that? Just mute self, right? And it doesn't like that because it can't borrow as mutable. The binding is already a mutable borrow. Oh, so we can't redo that. Does that work? Nope. Expected immutable reference found a reference Okay. I just pass in self. Okay. And I did change the, oops, wrong one. I did change it to add maze builder. So should we give it a shot? That's not it. That's not it. That's not it. Nope. And it crashed. Okay, so that means we actually tried to use it. And that's unfortunate because I don't... Oh, here it is. Yeah. Map builder, build map. I don't get a line number. Sometimes I do in the console. I see the line number of what's panicking. And it's probably there's an index that's overflowing or something. So then I come over here, and we might have to start it a few times. We might have to start a few times because we're not going to hit the random thing right away. But I might as well. I'll just try it a couple of times here, and then I can comment out because it takes a while to build. The reason it takes longer to build here is the save load system has to generate all the code for every single resource type or component type in ECS. There we go. Okay, we got it. So we went a little too far, and we were in... It doesn't tell me what line we were in. It's just in build map, generate world map. Oh, here, 226. Okay. Yeah, so it's in the copy. We went over with our copy. If our index is not half exactly, or maybe it rounded up, right? We did this here to say half and half, and then we doubled it and it went too far. So I can put in a quick hack just to get this thing working. If IDX is greater than or equal to map tiles len, then break, right? Integers should always round down. I agree, Epic. So I'm confused as to why we ended up... Oh, it's because we're adding one here, right? We're adding one, and so we're going to go one beyond. So maybe a better fix would be up here and say subtract 1 from each of these guys. Or subtract 2 and see what that gets us. I'll put both of these quick hacks in. And then we'll see if we can get a maze to generate. And if it doesn't go far enough down on the right and the bottom, then we can say subtract 1 instead. Oh, look at that. It's a little on the slow side, though, because it's waiting 300 milliseconds per snapshot. Maybe I should just take a snapshot every 3. Let's do that, just to see something, because I do need to wrap this up. I'm over my time limit now. So instead of generator take snapshot, let's say let mute snap level equals 0, and then we can say if snap level mod 3 equals 0, we'll take a snapshot, and then we'll just say snap level plus equals 1. Yeah, it's like map generation on a Commodore 64. There was a the very first roguelike I ever played was on a Commodore, not on a Commodore 64. It was on a PET, and it took a minute to generate the maze. And it would sit there looking, and the maze generation was very simplistic. I looked at the code later. It was all written in BASIC. There we go. So now we're doing 3 cells at a time. That's a little nicer, but still very, very slow. I would have thought it wouldn't be so interconnected like this. I would have thought there'd be more of a maze aspect to it. Because it looks like it's going to just knock down every single wall. And this could be the what I introduced, right? Yeah, it looks like it's hitting every single wall. And I don't think it's supposed to do that, right? If we look at the example. Yeah. All right. Well, that's something to debug for next week. I won't be around tomorrow or Friday. But we will, let's clippy this and get this checked in. Oh, we can fix this. Yeah, we don't need to do that extra. Right? And then, yeah, and then we can debug this on Monday. And it might be that that code that I modified, this here, this might be the bug. And we'll dig into that. Okay. Commit initial buggy implementation of a maze. All right, thanks for joining, everyone. Thank you, Epic, for your help and support and moral support. Yep. Let's there we go. And I will see you next week. For those of you who celebrate, happy Thanksgiving. For those of you who don't, happy rest of the week. All right, take care.